tools we use to write instructions for computers to follow. But to
So here, boys, we are gonna to learn about language of the computer. We said it's not language for the human beings to speak among each other. It's especially for computers. And we are gonna learn about it.
answer this question further, let's start by picturing a computer. Computers are machines that take an input and give an output. They're especially good at repeating tasks and performing calculations. Even though there are different types of computers, like laptops, phones, and even the computer that powers the little screen on your microwave oven, at the end of the day, all computers understand a common language, binary. Binary is a programming language made only of ones and zeros. The ones and zeros represent the states of on and off in the billions of switches on a CPU chip. When combined, the on and off switches represent data and instructions for how to complete complicated tasks and calculations. In this way, a computer's native tongue is binary. But as humans, it's hard to comprehend those ones and zeros. At a glance, binary looks like nonsense to us. Programming languages allow us to translate the abstract ones and zeros into something humans can understand. Programming languages fall into two different classifications, low level and high level. The programming languages that are closer to machine code or binary are known as low level languages. For example, assembly language is a low level language that's pretty hard to read because it's still
Saleh. So can we read this language? Is it understandable language for you? So we can't speak it among us, but the computer understand it. It's like a binary language, like 0 and 1.
structured to write instructions like but it's easier to understand than ones and zeros. Although difficult to write, low-level languages are fast
I opened the page 48.
and will function. On the other hand, high-level languages like Java, Python, and C++ are closer to how humans communicate. They use words in their instructions that are close to the language we use in our everyday, making them easier to program in and maintain. The downside is that they take more time to translate into machine code for the computer. As computers have become more powerful, the difference in runtime between low-level and high-level languages is often only milliseconds, which means that high-level languages can be used in more scenarios. So for the most part, high-level languages, which is why almost all software engineering jobs hire people who can program in high-level languages. High and low-level programming languages each have their own philosophies, advantages, and use cases. But at the end of the day, all programming languages are just different ways of telling computers what to do. Programming languages are tools, and deciding which one you need to use is much like the process of picking any tool. A hammer is easy to use to drive nails and requires less skill than using a saw, but try using a hammer to cut down a tree. As you explore the world of programming, understanding which languages are good for which tasks will become more clear. While humans and computers may not speak the same native tongues, programming languages are like a bridge. They allow us to translate our thoughts into instructions a computer can understand.
So when we talk about the language of the computer, it's only for programming. For example, let me tell you what is HTML. It's very unknown. It's very known language and familiar language.
It's CP.
HTML programming language, you can search about it. Look.
Everything in life is a negotiation.
Recent set of videos that we've done related to HTML, really. I've taken a severe beating in the latest one that I'm a disgrace to full professors that I don't know what programming language differs from a markup language, and my attitude is going to be, well, I stand by what I say. HTML is a very restricted form of programming language in my view. So we need to justify that, and I need to say at the outset that you don't need to see all the previous HTML videos in order to understand this one, because it really comes down to something that's actually very fundamental. In the end, it comes down to two different styles of programming language that are interrelated, but you can differentiate in a way between them, and when does one merge into another. And these two ways of doing programming are known in the trade generically as either the imperative style or declarative. Now, the one that most of you will be the more familiar with is the imperative, so we'll do that first. This is really just programming as you and I understand it. You take your language of your choice, assembler, Java, C, BASIC, whatever, and you are required to give a detailed specification of how you are going to do this problem. And as we know, this detailed specification might be simple arithmetic programming statements. It might require going round things in loops. It will certainly require taking decisions, so it will have if statements inside it. So if you like, ordinary, straightforward, detailed, nuts and bolts programming is in an imperative style, because you have to say how you are going to solve the problem. So I'll put how in quotes here, saying that leads you to if, for, arithmetic statements, whatever you need.
So this is setting out how you're going to do something. If this button is pressed, then do this.
Yes, yes. And the vast majority of programs that most people think of in terms of programming are done in this style. Now, what about the details? And actually, one style can merge into another. And I've got a very good example of my own, and we've done it on computer files. I wrote...
Look, how can we read this language? Muhammad, can we read this language? We can read it, but can we speak it among each other? Can we speak this language between us? Yazan, what do you think? Can we do that?
No, I didn't know. No.
Saleh,
No.
can we speak this language between us?
What?
Can we speak this language between us?
What is this?
It's a language, computer language.
This and what?
Yeah, it's not we can't understand it. Understandable. But the computer can understand it.
Okay, how?
It's simple. When you, for example, when you enter equals for the computer, it means you have to write, for example, the word Kate. So the computer, when you enter, for example, equals for the computer in this language, he will understand it. It will understand it like, please write the word Kate, or do an order like calculating some numbers. Okay.
A program to do the Ackermann function. I think it's my biggest hit so far, that particular video. And within the function Ackermann, we saw program statements, we saw use of recursion, we saw Ackermann calling Ackermann and all this kind of stuff, and finally returning and delivering back an answer. However, back in the main program, where I call up Ackermann with certain arguments, and I call up the Ackermann function as the argument, I don't worry about the implementation details.
So I highly advise you to learn the language of the computer, like Python, like HTML. It's very, very important.
How we can learn it?
You can ask your father about it, Yazan. You can learn it from computer courses. You can learn it online.
How they
Python.
put it? Mr. How they put it?
You can search on Google, how can I learn Python?
How? Okay.
How can I learn Python?
Ackermann.
Okay. This is very important for us.
When beginning
في مجالات شتى بدءاً من الرياضيات والطب.
Now we are gonna take like a tour inside the computer.
Do you remember when you first realized that your computer was more than just a monitor and keyboard? That between the mouse click and the video playing, there was something that captured your attention, understood it, and made it real? What is that something? Is it gremlins? Let's imagine that we can shrink down to the size of an electron and inject ourselves into a click of a mouse. If you took your mouse apart, you'd see that it's really a very simple machine. It has a couple buttons and a system for detecting motion and distance. You might have an optical mouse that makes these measurements with lights and sensors, but older ones did this with a hard rubber ball and some plastic wheels. Same concept. When you click the button on your mouse, it sends a message to the computer with information about its position. When your mouse click is received, it's handled by the basic input-output subsystem. This subsystem acts like the eyes and ears, and mouth and hands of the computer. Basically, it provides a way for the computer to interact with its environment. But it also acts like a buffer to keep the CPU from being overwhelmed by distractions. In this case, the I/O subsystem decides that your mouse click is pretty important, so it generates an interrupt to the CPU. Hey CPU, got a click here. The CPU, or Central Processing Unit, is the brains of the whole computer. Just like your brain doesn't take up your whole body, the CPU doesn't take up the whole computer, but it runs the show all the same. And the CPU's job, its whole job, is fetching instructions from memory and executing them. So while you're typing, maybe really fast, like 60 words a minute, the CPU is fetching and executing billions of instructions a second. Yes, billions, every second. Instructions to move your mouse around on the screen, to run that clock widget on your desktop, play your internet radio, manage the files you're editing on the hard drive, and much, much more. Your computer's CPU is one heck of a multitasker. But oh my gosh, there's a very important mouse click coming through now. Let's drop everything now and deal with that. There are programs for everything that the CPU does. A special program for the mouse, for the clock widget, for the internet radio, and for dealing with letters sent by the keyboard. Each program was initially written by a human in a human-readable programming language like Java, C++, or Python. But human programs take up a lot of space and contain a lot of unnecessary information to a computer, so they're compiled and made smaller and stored in bits of ones and zeros in memory. The CPU realizes that it needs instructions for how to deal with this mouse click, so it looks up the address for the mouse program and sends a request to the memory subsystem for instructions stored there. Each instruction in the mouse device driver is duly fetched and executed. And that's not nearly the end of the story. Because the CPU learns that the mouse was clicked when the cursor was over a picture of a button on the monitor screen, and so the CPU asks memory for the monitor program to find out what that button is. And then the CPU has to ask memory for the program for the button, which means that the CPU needs the monitor program again to show the video associated with the button, and so it goes.
Okay, thank you for watching. Now, please open this page. Ali, get ready for reading.
And let's just say that there are
Ali, page 438. Computers at work. How can you use computers at work? What does the word compute means? What does the word compute mean? Read it. The word compute.
Computers.